We know that energy is stored in electric fields and energy is stored in magnetic fields. Earlier we found that the density of energy in an electric field is 1/2 epsilon times E squared, and the energy density in a magnetic field is 1/2 mu H squared. In an electromagnetic wave, we're going to have energy being propagated by both the electric and magnetic fields. We know the magnitude of the electric field is equal to the intrinsic impedance of the material in which the electromagnetic wave is propagating times the magnetic field intensity. So we can rewrite the energy density in the electric field in terms of the magnetic field intensity and the intrinsic impedance of the material. And so we see that the energy density in the electric field is equal to the energy density in the magnetic field of a propagating electromagnetic wave. So the energy density in our electromagnetic wave is twice either of these terms. Let's substitute for one of these electric field intensity magnitudes the product of the intrinsic impedance of the medium in which the wave is propagating times the magnitude of the magnetic field intensity. The result is the energy density in our transverse electromagnetic wave is the product of the amplitudes of the electric and magnetic field intensities divided by the velocity with which they are propagating, which I'll call c here. Assume our transverse electromagnetic wave is propagating in the plus c direction and it's a uniform plane wave. Here we have a cross-sectional area of 1 square meter, and in 1 second our wave will propagate a distance of c times 1 second. So all the energy in this volume will pass through our plane of observation in 1 second. That volume is this distance, c times 1 second, times this cross-sectional area, 1 square meter. The energy in that volume will be the volume times the energy density in our electromagnetic wave, epsilon sub 0 times the magnitude of E squared if we're talking about free space, and that works out to the product of the magnitudes of the electric and magnetic field intensities. This energy represents how much energy is flowing per second through 1 square meter of surface. So E times H is the number of joules flowing per second per square meter. So that's the number of watts per meter squared. So E times H is the energy flow per unit area. That is referred to as the Poynting vector and is given this symbol uppercase script P. Oliver Heaviside and John Poynting independently derived this power flow equation. It's been named after Poynting, which is appropriate because it points in the direction of the flow of the power, the direction the electromagnetic wave is propagating. We derived the magnitude of the Poynting vector. We won't actually derive this vector form. Your textbook does it after the procedure that Oliver Heaviside used. You can look at that derivation if interested, but I don't think it adds to our understanding or mental representation of our power flow. John Poynting was actually one of Maxwell's students.